Welcome. This video will provide a short overview on how synthetic data is generated in 4 steps. Before we begin, a short note on synthetic data. Synthetic data is artificially generated data that can mimic real-world data. For more details about what synthetic data is and its benefits, take a look at one of our other videos titled What is Synthetic Data? Machine learning models and algorithms can be trained by data scientists and others to generate such synthetic data. In this video, we take a closer look at how the process looks like. In general, we can distinguish 3 types of synthetic data: fully synthetic data, partially synthetic data, and hybrid synthetic data. Fully synthetic data is completely generated from scratch. Partially synthetic data is a mix of real and generated data, and hybrid synthetic data uses real data to inform and guide the generation process. The synthesis of data can be described in 4 separate steps. First, one has to prepare one's data. Second, one has to choose a fitting method and tool for the data generation. Third, the data can be generated. And finally, one has to evaluate the generated data. Let's have a closer look at each of these steps. Before starting with the data generation, one needs to determine how the synthetic data should look like. If one wants to create synthetic data from scratch, one needs to think about the type of data that is needed. Is it statistical data in the form of a database, text data, or maybe pictures? Also, what requirements should the synthetic data fulfill? For example, if I were to generate a synthetic data set with 100 non-existing individuals, do I want to create information on their gender and age, or other characteristics such as their profession? On the other hand, if I want to create a hybrid synthetic data set, I need to make sure that my real-world data is clean. That means that there are no mistakes or biases in my data that could be replicated in the synthetic dataset. As a second step, one needs to determine a method for the data synthesis, that is, the generation of synthetic data. There are various methods that can be used. Which one is the right one depends on the goal of the data synthesis and for which cases the synthetic data will be used later on. For example, if I do not have access to real-world data, then I could use rule-based methods to create synthetic data from scratch. On the other hand, if I want to create synthetic data that mimics real-world data, I could choose statistical or machine learning models that first learn about the structure and content of the real-world data before applying that knowledge to the generation of an artificial dataset. When it comes to choosing a tool for the synthetic data generation, one has a choice between open source tools and commercial options. There are many libraries and packages for Python or R users to choose for data generation. They provide already existing models and algorithms for the synthetic data generation, but usually require some adjustments. The advantage of these tools is that they are free and usually have good documentation about how the generation process looks like. However, they do require some programming knowledge. Commercial options, on the other hand, are convenient as they can generate data for you. On the other hand, one has to invest money and some data may not be suitable for commercial synthesis, such as highly sensitive data that cannot be shared with such companies. Once a generation method and tool has been determined, the synthetic data can be generated, following the chosen method and tool's instructions. Once the synthetic data is generated, it is important to check the quality of the data. Does the synthetic data fulfill all the requirements set out in the beginning of the process? These requirements may differ with each generation process, depending on the intended use for the synthetic data. One goal could be to create a dataset that mimics a real dataset about a certain group of people. In a quality check, one would have to control whether the synthetic data contains no personal information and whether the synthetic data compares well to the real-world data. If any of the requirements for the synthetic data are not met, one has to go back to the beginning and check how the data's quality can be improved. For example, is the real-world dataset without any mistakes? Do the chosen method and tool fit the goal for the synthetic data, or is another method more suitable? The generation of synthetic data is an iterative process, meaning that it may take a few attempts of refining the process before ending up with the quality of synthetic data that is needed. In summary, there are various ways in which synthetic data can be created, and new methods are still emerging. The right method will always depend on the intended use of synthetic data. Therefore, continuous reflection and testing of the generated data is necessary. For more detailed explanations on how synthetic data is generated, take a look at our other videos.